Sorry about that, guys. My last video cut off. So this is the part 2 of mean absolute deviation. In addition, 2 additional measures of spread or variability that uses performance in a distribution are mean absolute deviation, other words also known as MAD, and standard deviation. Both of these measure how much the individual values in the distribution vary from the mean of the distribution. This is not the case with the range and the IQR, each of which measures only the distance between 2 positions. So how do you calculate the mean absolute deviation? Well, let's look at the White Sox runs allowed. The White Sox allowed 4, 2, 4, 6. There might be a typo right there. Let me look it up real quick. It should be 4, 2, 4, here. 4, 2, 4, 6, 5, 6, 6, 12, 1, 7, 10, 10. Yep. So on average, the White Sox, so find the average. What is the average of their runs allowed? When you find the average, put it here. To get an overall measure of how the to get an overall measure of how variable their performances are from the mean, we start by considering the deviations from the mean. A deviation, so this is the definition, measures how far an individual observation is from the mean. After calculating the deviation for each value in the distribution, we're going to use that to calculate the mean absolute deviation. Which measures the average distance each value is from the mean. So to calculate the MAD, which is mean absolute deviation, MAD, M-A-D, you're going to follow these steps. Well, the first step is to calculate the mean, which we've already done, and hopefully you did it. The next step is to calculate the deviations from the mean. So right here, I'm going to put in the values of the performances, or the runs allowed, which was 4, 2, 4, 6, 6, 6, 12, 1, and 7. And put your mean right here. The deviation from the mean means you mean. The deviation from the mean. Okay. So to get negative 1.3, all I did was 5.3. 2, 5.3. 3. And you get the picture. And then let's skip this part right here. This 0.7 should have been here. So 6 minus 0.3. So try to the now will be a time to pause the video so you can finish your step 3. Find the absolute value of each of the deviations. Is 3.3. Negative 1.3. 0.7 is so you leave it positive. You do not negative. We want all positive numbers. So finish filling out the rest of the chart. So far we've covered steps 1 through 3. The last step we need to cover is step 4. And step 4 says to calculate the mean of the absolute deviations. So that means all you're going to do is you're going to take that last row of numbers. So this row right here, here, add them together. Then divide by 10. And you divide by 10 because you have 10 options. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And whatever you get here, put here. That is how you find the mean absolute deviation. Your final answer should have come out to be 2.1 runs. If you did not get 2.1, bring your paper back to me and let me look over it to see what you did wrong. Or see if I had an error. Okay. The reason why we calculate the mean absolute deviation is because instead of just simply calculating the mean, consider step 2. When we added the deviations together, our sum would have been 0. So had we have added this column row right here together, the sum would have been 0. And the reason why your sum is always going to be 0 right there is because that is the distance from the mean. Your mean is the middle value of your data. So if we subtract everything from the mean and then add it together, it's going to get 0. It's the middle of the data. So let's talk about comparing the consistencies. Below are the dot plots that compare the White Sox distribution of the runs allowed and the runs scored. for the same year we talked about a while ago. Based on the dot plot, it seems like the White Sox distribution of runs allowed varies more from the mean of its distribution, meaning that their number of runs scored is more consistent than their runs allowed. To confirm this conclusion, we can compare the MADs together for each distribution. So calculate the MAD for the number of runs scored by the White Sox in the same 10 games. So now, right now in my column, I'm looking at these numbers. So I have 2, 2, 3, 3, 4, 5, 5, 5, 7, 7. So calculate the MAD using the same steps as earlier. So pause this video so you can calculate the MAD. You should have gotten your MAD as 1.5. On average, the number of runs scored by the White Sox was 1.5 from their mean. Since 1.5 is less than 2.1, this means that the White Sox offense was more consistent than their pitching and defense. So if this number, since that number was less than this number, that means they were more consistent. So if your mean absolute deviation is smaller, that means they are more consistent. In other words, there is less variability in their distribution of runs scored than their distribution of runs allowed. When you finish with this video and you have all your work shown, please come see me in the back.